Thank you. Okay, so I'm going to share the question now for you guys to attempt. So you'll have 5 minutes to do it. Then, if you have any extra questions, please don't hesitate to ask. Okay, so 5 minutes is over. If there are any questions, please do post it in the chat, and then we'll try and have that answered by the end of the session. So we are now going to start with the lesson. So firstly, we need to get our terminology, important terminology. So important terminology is basically what is a number pattern, what is a sequence. So that's basically just the order of your numbers. And then a series is a summation of all the terms in a sequence or given terms in the sequence. And then a term is just basically a single number in a sequence. So if you've got 1, 3, 5, 7, 9, the first term is 1. The second term is 3, right? So that's, and then you've got your common difference is just the difference between the terms. And then you've got your finite and your infinite series. So your finite series is what occurs when you know how many terms you are adding together. And then in your infinite series, the number of terms you need to add is too large. So then you have to set up a formula to kind of estimate where the number might theoretically end, right? And then now we are going to get into the arithmetic series and determining the formula. So, sorry, not arithmetic series, arithmetic sequence and determining its formula. So the basics of understanding the arithmetic sequence is that you have got a common difference. You've got your common difference, right? Which is the constant difference between terms in an arithmetic series. And how you find your next term is with the common difference. So say we've got the pattern 1, 3, as I mentioned earlier, 5, 7, 9. Your CD or common difference is calculated by subtracting the later term from the earlier term. So here, term 2 is 3 and term 1 is 1. So then to find your CD, you take T3 minus T1 and you have your 3 minus 1, and that gives you 2. Can you all see my board? Please just react or send a message in the chat if you can see my board. Okay. So, that's your common difference, right? And then another example would be, so your common difference can be negative or positive, right? So that can be, for another example, with a negative common difference would be 2, 0, minus 2, minus 4, minus 6, and minus 8. And your common difference is calculated by taking, like I said, the later term from the earlier term. So let's take, for example, in this sequence, term 5 and term 4. So that would be minus 6. My pen switched off, sorry. You get your CD. We said we're taking term 4 from term 5. And then that means you take minus 6 minus negative 4. And we know that a negative minus a negative gives us a positive. So then that's the same as saying minus 6 plus 4, and that would give us minus 2. So that's how you find your common difference in an arithmetic arithmetic sequence. Now we're going to move on to, we're now going to move on to derivation of the formula. So you first start with T1 is equal to A. So your first term is A, right? And then maybe let me keep an example at the top for you to refer to. So T1 is A. In other words, T1, this T1, this is T1. Okay, so in this case, our A would be 1. And then your next term, T2, as I mentioned earlier, you use your common difference to find the next term. So in this case, we'll denote our common difference as D. So then that would be T1 plus D. Okay? And that is equal to, as we mentioned here, that T1 is A. It's A plus D, right? And then the next would be term 3, which is equal to term 2 plus D. Because as we mentioned again, your next term is found by adding your common difference. But as we can see here, term 2 is equal to A plus D. I hope that is clear. Term 2 is equal to A plus D. So now we are going to substitute A plus D for term 2. So that is going to give us A plus D for term 2 plus D. I'm just putting in the brackets so you can see what I've substituted. That will now give you A plus 2D. All right. And then we've got the fourth term, which is given by T3 plus the common difference. And as we see here, T3 is equal to A plus 2D. So we are going to substitute that again. And then we're going to add the difference to that. And then, simple maths, A plus 2D will give us A plus 3D. Right. So now you see T4 is equal to A plus 3D. T3 is equal to A plus 2D. T2 is equal to A plus D. T1 is equal to A. Is it clear why these letters are the way they are? Do you guys understand the sequence of the derivation so far? Okay, let me try and explain again. Let me erase this and then I'll explain again. So when we want to derive the formula, we want to create a general formula that we can refer to whenever we want to find any term in an arithmetic sequence, right? So do you understand the pattern in an arithmetic sequence? That in an arithmetic sequence, there is a common difference, and that common difference is always constant. It's always constant for an arithmetic sequence, as you can see in my example above here. This example, right? There is a constant difference. So if you take 3 minus 1, your difference is 2. If you take 5 minus 3, your difference is 2. If you take 7 minus 5, your difference is 2. If you take 9 minus 7, your difference is 2. So do we understand that there is a constant difference between consecutive terms? Does that make sense? You can react with a thumbs up, send a message on the chat. Does it make sense? Does it make sense, guys?
Yes, they did give a thumbs up.
Oh, okay, okay. Sorry, I didn't see that. Okay. And then now we are going to move on to derivation of the general term. So the general term is the formula that we are going to use to find any term within an arithmetic sequence. So now I'm going to start. Maybe I should, no, let me leave it like this. Let me not confuse you guys anymore. So in the derivation of the formula, you need to start with term one because they can test this. They can test you on derivation of the general term for arithmetic sequence or geometric sequence or the derivation of the series formula. So it's important. So you can write it down. Maybe if you write it down, it will make more sense. So we start with T1, right? T1 will be given a value of A. And you can refer back to the number pattern above to understand. You can like equate it to the number pattern above to understand what I'm saying. Right? We've got T1 is equal to A. And then we have T2 is equal to T1 plus your common difference. Because remember, we said T2 minus T1 will give me my difference. T3 minus T2 will give me my difference. So if I do the inverse, if I take T1 plus my difference, I'll get T2. If I take T2 plus my difference, I'll get T3. Okay. So that's just basically what I'm writing down. And then because we said at the top that T1 is equal to A, we're now going to substitute this T1 with A. Okay? And then we move on to term 3. So we are adding our difference to term 2. I hope the terminology is not confusing. So in the previous, we said T2 is equal to A plus D. Let me just take out the brackets. All right? So A plus D is going to be substituted in there. And we don't forget this other D here. So that's the D we're adding. Then we have D plus D will give us 2D. So you have A plus 2D. Okay. And then T4 is equal to T3 plus D. And then that will equal, again, this is what we're using. A plus 2D plus D. And that will give us A plus 3D. Okay. And then, now, do we understand this now? At this point, do we understand? I'm not sure if I'm going to see your reactions, but yes, D is the difference. Okay, okay. Now, when we finally write down the general term, we write it in terms of N. So as you can see here, T1 is the first term. T2 is the second term. T3 is the nth term, is the third term, sorry, and T4 is the fourth term. So then now in the general term, you write, the general term is basically the nth term because you don't know which term you want to determine yet. So we write it down as Tn is equal to A plus n minus 1 D. So where is this n minus 1 coming from? If you look at this T1, there's nothing there because 1 minus 1 is 0. So you'd have 0 times D. And then T2, A plus D. So basically, if you said A plus, so that is the same as saying A plus 2 minus 1 times D. What's 2 minus 1? 2 minus 1 is 1. 1 times D will give you D, so you'll get this, right? So you can attempt to see if you understand the formula and its derivation by referring to a number pattern. So you can use this number pattern just to remind you of how to derive the formula. And then an important thing when testing for the arithmetic sequence is you can just double check that you correctly identified the sequence by checking that your difference is constant. So if you have D is equal to T2 minus T1 is equal to T3 minus T2. If you just want to make sure, like maybe you're writing in the test and you want to make sure, like 100% sure that you correctly identified, just use this and then it'll tell you if it is an arithmetic sequence or not. So the important thing is common difference. Just always remember common difference between consecutive terms tells you it's an arithmetic sequence, right? Are we all okay with arithmetics? Okay, I hope. Okay, yeah. Now we are going to, I'm sorry, I don't know how to move around the board, so I'm gonna need to erase this. So now we're gonna move on to
Sorry,
geometry.
Kamukela has a hand raised. I'm not sure.
Oh, okay. Kamufalo, what is your question?
Oh, hi. I wanted to ask, so if, as you said, T1 is close to A, right?
Yes.
So if T1 is close to A, we're supposed, and I don't know how to say this, but aren't we supposed to say 3 plus 1, then 5 plus 3, then 7 plus 5, then 9 plus 7?
No. May you please repeat your question?
To find the difference, are we not supposed to say 3 plus 1 and 5 plus 3, like so on and so on?
No, to find the difference, you need to take the T2 minus T1. That will tell you the difference between these two terms. So that would be 2. And then here you take T3 minus T2, then you will get 2. You take T4 minus T3, and then you'll get 2. Do you get what I'm saying?
Yes. So is that why you said 2 minus 1?
You mean for derivation of the formula?
Yes.
Okay, let's go back. Are you talking about this part?
Yes, this one.
This one.
Yes.
The reason why I said that, okay, I don't want to confuse you. So let me go to the general formula. So this 2 minus 1 times D was just referring to the general formula, like why the general formula is written out like this. So if you look at the pattern, let me erase this. If you look at the pattern of these last sequences, what's going on? If you look at the pattern with these last sequences, right? Look at your term number. Your term is 2. Your term number is 2. And then here you've got D. Here your term number is 3. Here you've got 2D. Your term number is 4. Here you've got 3D. That's why they say N. So N is your term number minus 1. So if you look here, your term number here is 2. minus 1, that's 1. That's why it's just A plus D. If you look at your term number here, it's 3. 3 minus 1 is 2. That's why it's 2D. Does that make sense?
Yes.
Okay. Okay, now we're going to move on to arithmetic sequences. Not arithmetic, I'm sorry, not arithmetic, geometric sequences. So in a geometric sequence, the pattern that you need to understand is that there's a constant ratio, whereas in arithmetic, it was constant difference, but in geometric, there's a constant ratio. So I'm sure you all understand what ratio is, right? So if I've got, for example, 5, 10, 20, 40, 80, there is a constant ratio between the terms. Let me just write this in a different color. So there's a constant ratio between the terms. So here, my ratio, okay, that is, no. So here, my ratio would be, okay, I don't know what's going on with these pens. My ratio here is given by T1, T2 over T1. That should be equal to T3 over T2 because it is a constant ratio. So the ratio of this should be equal to the ratio of this because we said it's constant. So we can test this by using our number pattern. So we've got 10 over 5 is equal to 20 over 10, right? Is equal to 40 over 20. And what will that give you? It'll give you 2 every time. So that means, yes, this is a constant ratio. And the R value is 2. So yeah, that's basically what you have to understand with the pattern in geometric sequences. Are we all okay so far? Okay. Okay, cool. Now, derivation of the general term. So in derivation here, T1 again is equal to A. So this is just a variable, okay? It's just to help you understand the derivation, okay? T1 is equal to A and your ratio is equal to R, okay? We understand that. Now, if we want to find T2, we need to multiply that term 1 by R. Okay, let me correct this. You need to multiply term 1 by R. And because in this part we said term 1 is A, it would be A, just put that in brackets so you can see, times R, which is the same as saying AR. T3 is equal to T2 times R. Here we said T2 is equal to AR. So it would be AR times R. So when we multiply two variables together, it's squared, right? You add the exponents. So it's AR squared. T4 is equal to T3 times R. And then because we said T3 is AR squared, we say AR squared times r. And what do we do when we multiply variables? We add the exponents. So then we have ar to the power of 3. So kind of similar to the previous derivation, you notice a pattern. So here you've got T2, your n is 2, so the number of your term is 2. And look here, it's basically to the power of 1, right? Here, your n is 3 to the power, your power is 2. Your n is 4, your power is 3, right? So that means that your nth term for a geometric sequence is equal to a times r to the power of n minus 1, which is the same as saying ar to the power of n minus 1. That does not look like an r. A r to the power of n minus 1. Okay. Do we understand that? Are we all okay? Okay. All right. Okay. Now, another important thing when you're double checking that it is a geometric sequence, just take your ratios. So you take your second term over your first term, your third term over your second term, your fifth term over your sixth term, your 10th term over your 9th term. That ratio should be the same because it is constant. So that's it for sequences, because I know you guys did quadratic sequences in grade 11. So that's just revision, right? I hope so. T1 can be B, it can be X, it can be Y, but like because of like standard practice, and because you'll find these different variables to calculate so many different things, it's just easier to remember that, okay, number patterns, we use A, R, and D for the first term, for the ratio, for the difference. It's just easier to have like a standardized variable associated with certain derivations. Yeah, it's just so you don't get confused. Yeah. Okay. So now we are going to move on to arithmetic series. So we've got finite arithmetic series. So that's like the sum of a finite number of terms. So you know where your arithmetic series ends. So if you've got 50 terms, you know that, okay, I'm measuring 50 terms because it goes 1, 3, 5, 7, 9, 11, 13, 15 until the 50th term. So yeah, it's important for you to understand what that means, and yeah, how to find the sum and also derive the formula. So we are going to start with the number pattern, just for you to always have a number pattern to reference so that you don't get lost. That really helped me with my like tests and exams. Always have a number pattern to refer to. So here we'll use 1, 3, 5, 7, 9. Let me extend it a little bit. And it goes on, right? So say you're given a question that asks you to, I'm sure you're all familiar with the notation for finding the sum, calculating the sum. I will explain like the notation and stuff, but maybe in another lesson, maybe in the next lesson. Let me just check. It seems like is there something in the chat, or am I delusional? Okay, there's nothing. So now what you're going to do, right? You're given this, right? And the top value tells you your upper limit. So basically, let me start with the bottom value. Start from the beginning. So the bottom value tells you your lower limit. So it tells you where to start from. And then your upper limit tells you where to stop. Okay. So if I say calculate the sequence of this equation of this pattern for 50 terms, for a total of 50 terms, you're going to, well, if you have all the time in the world, you're going to add until you reach the 50th term, right? Which is 99. But then a formula has been derived for you to spend less time doing that, for you not to spend time doing 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus this plus this plus this until you get to the term you need to get to. So that's what we're going to do now. We're going to derive the formula. Okay, so then we have S50 is equal to, as I mentioned, 1 plus, so it's just, I'm just basically rewriting this, or well, this part of it. Basically rewriting this part of it by writing this. Okay? And then n equals 1 just tells me which term I need to start from. So my first term is obviously 1, right? Plus 3 plus 5 plus 7 plus da 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 da. And then maybe we'll add the last 4 terms because we started with 4 terms, plus 93 plus 95 plus 97 plus 99. You see, this is why it's important to always have like a reference number pattern. And then you will add it to the reverse of this. So it would be 99 plus 97 plus 95 plus 93. You don't need to know the history of or the reason why we do this. Just know that we do it. Plus 7 plus 5 plus 3 plus 1, right? So we are adding this and this together, right? So when we add them, we have 2 S50, because when you multiply 2 of the same terms, you get 2 of it. So when you add 2 of the same terms, you get 2 of it. So 1 plus 99 is 100. 97 plus 3 is 100. 5 plus 95 is 100. 7 plus 93 is 100. Then continue. So you basically just keep getting 100, 100, 100, 100. Is that the correct number of hundreds? Okay, we'll answer that question at the end. Let's just try and do as much as we can within the limited time. And then okay, once we've done that, right, we obviously going to have 50 hundreds because we are calculating the total of 50 terms. So it's going to be 100 times 50. So then you're going to have what? 5,000. S50 is equal to 5,000, right? And then let me just go down here. Then you're going to have to divide. So you want to isolate your S50, so you're going to divide. So you have S50, I hope you guys can see, is equal to 5,000 over 2, right? And then 5,000 over 2, S50 is equal to 2,500. Okay, so that's just the derivation with substituted values. So when you derive though, you need to use the variables a plus d, a plus 2d, and then here you'd have l minus 2d, l minus d, l d plus l alone. I will send the notes through, don't worry. So that is how you derive the formula. So just like if you substitute the variables into that, you should get if you get the if you substitute the variables, you should get the formula. So it will be in the notes, don't worry, it will be in the notes. This is just like for you to comprehend how the formula like works, how it makes sense. So another way to write this, right, in terms of a formula would be Sn is equal to n over 2 by 2a plus n minus 1d, right? So that is your general formula for determining an arithmetic series, a finite arithmetic series. Most of your arithmetic series are always going to be finite. And then this is for when you don't know the last term. This is for when you don't know the last term. And then when the last term is known, then you have Sn is equal to n over 2 by a plus l. It will be in the notes that will be sent to you guys. So it will make sense when you look at the notes. And then, yeah, that's basically it for arithmetic sequences and series. And then it seems like we are running out of time. So we will continue the second half of the lesson. I will confirm the time, but we will continue the second half of the lesson, which will compose of the finite geometric series and sigma notation and infinite series. That's basically it for sequences and series. You will also get a practice question to do on your own, and then if you have any questions, you can send them through. But yeah, there will be like formal communication about the practice questions. But before we leave, there is one more practice question that I want you guys to try. Let me just share my actual screen now. Okay, so before we do the practice questions, are there any questions on what we've done so far? Or are you guys all okay? Okay. Okay. So let me see if I can open. Let me see if I can open it. Okay, there it is. Just need to share. Okay. So you can attempt to do, yeah, you can do everything. You can do everything. Yeah. So I will give you, let's see, until 8:05, and then yeah, you can ask any questions based on this or the lesson, and then after that I think we'll be done. Okay, I think that's enough time. Are there any questions? No questions? Okay, thank you for attending the session. Can the host please take over and just share the information on where the notes will be sent, when, and how?
Okay. Thank you. So the notes will be sent via email, and attachments as well that will lead you to our YouTube channel and the Google Drive. Excuse me. And we will share on WhatsApp. We'll share those links on WhatsApp as well. And during the course of the week, we will also send the roster of the other sessions and the topics that we will be covering. But thank you very much, Lerato, and thank you, Dennis, for joining us today. The session has come to an end. I'm not sure if there are any more questions. Okay, that means that we are good. Okay, thank you. Bye-bye.
Bye.